Okay, so we're just going to run through chapter 11. It's pretty straightforward. It's a nice chapter to finish on. So this is how I'd like us to sort of get into the chapter. We've got 3 lessons coming up quite quickly now, which is quite nice. So today I would like you, there's no extra learning for 11A. So we'll really, your goal is to try and get 11A done for Friday. Then on Friday, 11B done for Tuesday. So I don't think there's any need for a quick live chat on Friday, because I'll just cover those bits and pieces in a minute. And then Tuesday, perhaps we could just quickly chat base again before we launch into exercise 11C. So all I want to do is turn the pages now on being able to do 11A and 11B. So this chapter is all about variable acceleration. So this is not SUVAT. Obviously, SUVAT is when we've got constant acceleration. So variable acceleration, this is going to be when we have to differentiate or integrate to move between the various, to move between displacement, velocity, and acceleration. So we kick off with just reminding ourselves what obviously variable acceleration means. Obviously, on a velocity time graph, we've got our acceleration. We're used to it being a straight line when we were doing SUVAT. Clearly, that's increasing acceleration, and clearly that's decreasing acceleration. So no huge surprises there. Now, building in there really is nothing too complicated with the first bit. So I just have a quick look through the examples, and the exercise is very straightforward. You might have to do the 1 or 2 bits of differentiating where you just want to work out the maximums, but it's straightforward enough. I've uploaded all these slides, the PDF, onto Show My Homework. So if you want to look at my slides, you can do. But it's just straightforward enough. You know, find S when T is 1. Well, substitute 1 in, and so on. So it's pretty straightforward. Just follow the instructions. So yeah, find the change in displacement between T being 2 and T being 4. Clearly sub in 2, sub in 4, and take one away from the other. So it's really quite a gentle start. Yes, and part B there, we had to find the greatest speed of the particle between 0 and 4. So there was a little bit of differentiating going on. So, but it's pretty straightforward stuff just to do 11A. And obviously, as always, if there are any bits in it you're not comfortable with and you can't figure it out from these slides, just send a message through to me either on Teams or by email, and I'll just upload a video explaining the question. So I'll anytime, that doesn't have to be during one of our scheduled lessons. Any question you're stuck on, just let me know, and I'll just upload a video explaining how to do it. So that was 11A. Then I'm just building up to 11B. So I know you all know how to differentiate. Okay, you all. But if you've just slightly forgotten that slide, just reminds you of the process. Yeah. So this is the bit I just wanted to remind you about. Okay. So we're moving between displacement, velocity, and acceleration. Okay. So if we've got displacement, the rate of change of displacement, the rate of change that you're covering distance, is velocity. So if we differentiate a displacement equation, that gives us velocity. And then in turn, the rate of change of velocity is acceleration. So if you differentiate velocity, you get your acceleration. So differentiating to go left to right. And similarly, if you're going right to left, you integrate. You integrate acceleration to get velocity. You integrate velocity to get displacement. Now, it's quite nice, I think, just to tie this in with SUVAT. Now, of course, SUVAT is when we've got constant acceleration, but this differentiating does still apply. I think I've run through this with you before, but it's a good opportunity to cover it again. So from SUVAT, we know S equals ut plus half at squared. Now, if we differentiate that, we do indeed get v equals u plus at. Okay, because so differentiate that, you get v equals u plus at, and then if you differentiate that again, you're just left with a, the acceleration, being a constant acceleration. So again, that's what you'd expect it to be. So it's quite nice to see that this differentiating process does apply to SUVAT, as well as when it's variable acceleration. Right. So again, so all you've got to do with these questions is just differentiate where appropriate. So example 4, we're given the displacement equation. They called it X, I've just changed it to S so we're consistent. You're being asked to work out something to do with velocity, so you obviously have to manipulate your displacement equation before you can do so. So you differentiate this, you get velocity, so we've just differentiated this, so 40 cubed minus 32. So, and then once you've got your velocity equation, you can then go and answer any questions in velocity. For part C, when we're going to have an answer questions on acceleration, clearly we need to differentiate the velocity equation. So there's a velocity equation that we worked out up here. So acceleration, we're just going to differentiate again, so multiply by the current power, reduce the power by 1, we get acceleration being 12t squared, and then we can answer it when t is 1.5 by subbing in 1.5. So, and that's it. I think they've just got the one example. So then we just straight into the exercise. So it's good differentiation practice. So do make sure that you work your way through 11b. As I said, it's doubling up. It's obviously important for mechanics, but it's a good opportunity to revise our pure skills. So we're working through 11b. Again, I think I've done every single slide here. Just differentiating, nothing too complicated. Yeah, and then that's as far as I want us to get. We will go through 11.3. That's the one I said we go from Tuesday. So if you wouldn't mind, please, just trying to work through that 11A and 11B, get it done by Tuesday. As I said, I'll be online during our lesson on Friday, but anytime you've got a query, just send me a message on Teams or by email, and I'll get back to you. So that's it, really, guys. I think I'll leave you just in case you guys want to have a chit chat. Don't start doing that until I've stopped recording. So stop recording.